How many columns would you need?
Is it a pure syllogism or pure hypothetical?
Yeah, only it's not a syllogism, as you know.
Yeah, there's a few more.
It's pure hypothetical, yes.
64.
Wait a minute. No, how many columns? The uppy-downy ones.
8. 9.
Well, there are 9 of these, but you will also need,
Oh,
you will need 9 more, 1 for each letter, right? So 18 columns. 18 columns, how many rows? No, no, not 64. What's that? 512, yes. Because, how do you work that out? Probably because you're a computer nerd. Yes, 2 to the power 9. I know 2 to the power 8 is 256, because that's how many numbers you can convey in a byte, I think. And double that is 512. Yeah, so you better get going, hadn't you? 18 by 512. Your table. Perhaps if you put, all right, I won't make you do it. But we have to be able to prove that something like this is valid. And we don't want to have to do a freaking massive table. Wouldn't it be nice if we could, if there was a shortcut method? Oh, there is. Of course, it says so on the syllabus. There is a shortcut method. Well, I've already kind of given hints about what how to take shortcuts previously. Like when I was saying, how many more rows do we have to check? And we didn't have to fill out the whole table. We just had to check. What rows did we have to check? Where the conclusion is false. So in fact, in the shortcut, in the test for validity, what are we looking for? When we make the table, what are we looking for? How many rows are we looking for? Just one. A special row where all the premises are true, and the conclusion is false. All right. What we're going to try and do with the shortcut method is we're going to try and reverse engineer that row. So what we're going to do, the shortcut truth table is going to look like this. Instead of 18 by 512, it's 9 by 1, a bit smaller. Okay? But what we're going to do is, actually there's a good analogy with what you did on your homework. Remember, on your homework, you had 2 cases where I gave you a long, ugly proposition that might have looked, I don't know, something like this. You know, if P then Q or R, negation of that, if and only if S and T. Something like that, a big ugly proposition. And then I said, I told you, plug in these truth values and work out the truth value of the whole thing. In fact, I only gave you 1 truth value because you could work it out that way. Right? And that's sort of what we've been doing. You've been taking the truth values of the component propositions and you've been plugging them into longer things and working out the truth value of the long thing. And for every combination of truth values, you've worked out the truth value of the long thing. So that's sort of the bottom up. You start by knowing the truth values of the individual propositions and working out the truth value of the compound proposition. Yeah? Well, we're going to do things in reverse, because just like on your homework, there was another one where I gave you something like this, only I told you that the whole thing is, say, true. And then you work backwards to work out the truth values of the component propositions, right? Because I gave you one where there was only one possible way that could make it true, if, you know, A was true, B was false, or whatever. That's sort of what we're going to do with the shortcut method. So, we start by making our table. Again, a column for each premise and a column for the conclusion. Double line to show that it's the conclusion. Now, what's the line that, if we made the full table, what was the line we were looking for? Where the premises were all true and the conclusion was false. Okay, so what we're going to do is we're going to make the premises true and the conclusion false. Now, of course, the premises are each compound propositions. So if I make this premise true, where would I write the true? Under the arrow. Now, this is a conditional. How many ways are there for a conditional to be true? 3. So if I started by making this premise true, I would have to look at all 3 possibilities. And actually, I would have to do 3 lines. But I'm lazy. I don't want to have to do 3 lines. So instead of starting by making the premises true, what should I do? Start by making the conclusion false. Why, in this instance, would that only require 1 line?
Because there's only one way for a conditional to be false.
That's right, because what do we know about conditionals? They can only be false one way. So I write the false under the conditional, and I circle it, because it's the truth value of the whole proposition. And for that to be false, A has to be true, and I has to be false. Yes, because we've memorized our truth table for conditional, and we know that conditionals are only false when the antecedent is true and the consequent is false. All right. Now I know what A. Now I know that if I drew the whole table, the only times the conclusion would be false would be when A is true and I is false. So what else can I fill in immediately? Right, I find where else A is, and it's over here, and I know that it has to be true on this line. And I find where else I is, and it's over here, and I know that it's false. That's going to help me. That's going to mean that I no longer have to do 3 lines to make this premise true. Why? Suppose I want to make this premise true. Why don't I need 3 lines anymore?
It's the only way to make that true is B if B is true.
Yes, because now I know that A is true. The only way for this to be true if A is true is if B is also true. Because if B was false, this would be false. So if B can't be false, it has to be true. So when you're doing the shortcut method, you only ever write a truth value under a letter when there's only one thing it could be. Bless you. If there's more than one thing it could be, then you have to add to the number of lines. If, for example, I started by making this true, then I would have to do 3 separate lines to cover all possibilities. But if you're clever, and this is why the shortcut method requires a little bit of thought. The long method is boring, but you don't really need to think. You just plug in truth values. Here, there's kind of a strategy to it. You're sort of zipping backwards and forwards, only filling in a truth value where there's only one thing it could be. So it's a little bit harder, but it's a little bit more interesting. And it's a lot less work, provided you're smart about it. All right. Now, what can I immediately do? Well, I know that B is true, so I fill in here. Then, I have to make a premise. I'm trying to make all the premises true. Which one should I try next? How about this one? Why? Because if I start with this one, I'll have to do 3 lines. But if I go here, there's only one way for this to be true, which is if C is true. Oh, and look, C is over here, and then if I make this true, D has to be true. You can see there's kind of a domino toppling effect.
How do you know that the whole thing is true? Or how do you know? Or you just guess?
I don't know that it's true. I want to... What I'm doing is saying, look, if I made the giant table for this, right, I would get all kinds of values. Sometimes this would be true, sometimes it would be false, right? But I wouldn't care about the lines where any of the premises are false. Why not? Because I only care about one line. When you make the table, you're looking for the one line where? So I'm trying to make that line, right? Now I can't do it by cheating, by just saying, okay, let's make A true and B true here, and then let's make B false. Wait a minute, I can't make B false if I made it true over here. So I have to make it consistent. If A shows up anywhere, it has to be the same truth value wherever it shows up, right? So I'm not just making stuff up. And in fact, that's why I went with this one, because there was only one possible way for this to be false. If A is true and B is false. So I can sort of work out that if I did the big truth table, that would be the only rows I care about when A is true and I is false. Because that would be the only ones where the conclusion is false. And then I plug in A here, and then you can see how it goes. So this will be an actual line on the truth table. And let's see if on that actual line on the truth table, where A is true, B is true, C is true, D is true, E is true, and I is false, let's see if that would make all the premises true and the conclusion false. It's the only line that would make all of these premises true at the same time the conclusion is false. Let's see if it works for the rest of them. What do you think? Will it work?
No.
Why not?
Because I is false.
Because I is false. And why not anyway? Because if it did work, what would that prove? This argument is invalid. But what do you think? Is this argument invalid? Why not? Because it's a pure hypothetical, right? A leads to B, B leads to C, C leads to D, blah, 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 leads to I, so A leads to I. It's sort of an expanded hypothetical syllogism. It's like lots of hypothetical syllogisms put together. So it's pretty obviously valid. So we're going to fail at some point. We're trying to show that it's invalid, but it isn't. So the argument won't let us do that. Because if we actually made the giant table, there wouldn't be a line where all the premises are true and the conclusion is false. So in trying to do this, we're going to fail. Let's see where it happens. Some of you have already worked out where it happens. So I'm making this true. The only way to make this true when E is true is if F is true. So F is true. The only way to make this true is if G is true. So G is true. The only way to make this true is if H is true. Wah, wah, wah. What's the problem? I cannot make this premise true. I got so close. I can make the conclusion false at the same time that all these premises are true. But that's not good enough. They have to be all the premises true at the same time that the conclusion is false. And that didn't happen. So, shortcut method, which we'll talk about more, well, I'll talk about in a video form. If you fail, it's valid. If you succeed, it's invalid. One last thing. I started by making the conclusion false. And that told me that A was true and I was false. Right? So, let's see. Like this. Right? Now, I then went to this one next, because there was only one way that could be true. Where else could I have gone? To this one. There's only one way that this could be true. Which is if what?
False.
If H is false. And then I could work backwards. And if I did it that way, where would I hit my snag? I would get this far. So I would manage to make all of these true, but then it would be false here. Okay? So what does that show? Two different tables. Does that mean one's right and the other one's wrong? No. Because there's two different ways to do this. Just because once you made the conclusion false, you can either start on this one or you can start on this one. But either table is correct. Because in both cases I've shown that it's impossible to make all the premises true and the conclusion false.
I'm going to do question 1. This is a little awkward. If I knew how to set up videos better, I wouldn't be doing this, but I'm going to do question 1 of practice quiz 13.2, page 369. There it is. Okay. Now, you can start anywhere. Basically, as you remember, the point is to try to make all the premises true and the conclusion false. And if you succeed in doing that, what you've proved is that there goes a tram. You've proved that the argument is invalid, because if it was valid, it would be impossible to make the premises true and the conclusion false, because the premises would guarantee the conclusion. So making the premises true would automatically make the conclusion false. Would make the conclusion true, because the conclusion is contained within the premises. So if we're able to do it, if we're able to make the premises true at the same time that the conclusion is false, the argument must be invalid. And in the textbook, it tells you always to start by making the conclusion false. And usually this is the best approach, just because there are more cases, specifically disjunction and conditional, where there's only one way for it to be false, but there's 3 ways for it to be true. And really, the strategy is to only fill in truth values when there's only one truth value it could be. But occasionally, it will make more sense to start by making a premise true. And we'll look at a couple like that soon. But let's start with this one. Okay, so you can look it up in your book so you know what I'm talking about, seeing as I can't do it and show you at the same time. I'm going to start by making the conclusion false. Let's see. Now the conclusion is not C, because this is question 1 of practice quiz 13.2. So that means, of course, that we make C true, because we're making not C false, as you can see. No pun intended. Alright, now the very first thing that we can do the very next thing we do is to take that truth value for C and plug it in over here, because C has to be the same truth value all the way through. Alright. Now what that means is that there's only one way for this disjunction. Actually, no, that's not true. Yes, and in fact this is a good point. Which of these premises should we do next? And the answer is this one, because actually this premise is already true. So it doesn't matter what B is. So we shouldn't fill in a truth value for B because it hasn't been decided yet. But I am going to fill in a T under the disjunction sign, because we know that this premise is already true. Alright, now we're going to try and make this premise true. So I write the T and circle it for the entire premise. And of course, being a conjunction, there's only one way for it to be true, when both A and B are true. And now we've settled what B has to be over here, we can fill it in over here. Alright, so what have we established? I feel like Steve on Blue's Clues. What have we established? Well, yes, you're right, viewer. We've established that this argument is invalid. So we're going to write that. Invalid. And when you prove that an argument is invalid, I want you to write a little list of the letters and the corresponding truth values that make all the premises true and the conclusion false. I'll show you what I mean. So for this one, it's A is true, B is true, and in fact C is true. So we would write it out like this. Now, when you find that an argument is valid, you do something different, because if you remember, when it turns out to be valid, we arrive at a contradiction. But and when that happens, it means that what I mean by contradiction is you will fail to make one of the premises true, or you will fail to make the conclusion false. Usually one of the premises, because you usually started by making the conclusion false. But if you start with the premises, and making all the premises true ends up forcing the conclusion to be true, then that's where your contradiction is. You know, you will try and make the conclusion false, but the values for the letters that are forced by the premises being true will make the conclusion true. Or the values of the letters that you get from making the conclusion false and most of the premises true will force one of the premises to be false. But anyway, why don't you try some of the exercises in Practice Quiz 13.2. What else have you got to do? Get on it. Good. Alright, have you finished that? I was just napping. I'm a bit jet lagged. Alright, well now, if you've done a few, I'm going to do this one for you. So this is question 12. If you've already done it, well, we can compare notes. If you haven't, let's see how to do it. Now, as with all of the examples in the book, in this exercise, there's only one way for the conclusion to be false. So we can start by making the conclusion false. But of course, we can also start by making A true, because there's only one way for this premise to be true, seeing as it's a single letter, and that's if A is true. So actually we can fill in both of those. So, to make if D then E false, there's only one way that a conditional can be false, which, as we all know, is the antecedent is true and the consequent is false. So we can fill in those values. So D is true and E is false. And we can also make A true. And then we can carry over all of those values to the remaining rather complicated premise. Alright, this is dynamite video. So here we go. We've got the conclusion is false, so D is true and E is false. We've got A is true. We plug all those in, and I've stated that if D then E here is false, which is the little triangle there. So we now know that C and if D then E must be false because it's a conjunction, and one of these is false. So I'm going to fill that in as well. Let's use an upside down triangle for that one. Now notice, I haven't filled in the truth value for C here because we haven't been forced to any single particular truth value. So I'm going to leave that blank and see if the remaining part of the premise will force us to put a single value there. So let's see. We're trying to make the whole thing true. But, of course, what we now see is that because this is a disjunction, A or B is already true, because A is true. So, we've got, I'm going to use a little upside down triangle there. We've got, it's already settled that this whole conditional must be false, because its antecedent is true, and its consequent is false. And that's without settling the values of B or C, because it doesn't matter what D is, A or B will always be true, and it doesn't matter what C is, C and something false will always be false. So we can just put, well, what that means is, first of all, we have shown that this argument is valid, because we were unable to make this premise true. The values that made this premise true, combined with the values that make this conclusion false, force this premise to be false. So what we do is we write a false under the main connective, which is the conditional, circle it, and then we draw an arrow going to that false, the part where we failed to make all the premises true and the conclusion false, and we write valid. Like that, right there. So you say valid, and you draw an arrow to the part of the argument that proves this. In this case, it's this premise being false. Alright, next I'm going to try question, what is that? Oh, this is question 15 on page 288. I'm going to try that next. If you want to give it a shot first, well, now would be a good time to try it. I'll give you a few seconds. That should give you enough time. Now, the first thing you should notice about this one is that the conclusion can be false in more than one way. So if you start with the conclusion, you're going to have to draw two lines. You would have to draw a line for when G is true and H is false, but you'd also have to do another line where G is false and H is true. That's if you start with this one. So starting by making this false is going to force you to do more work. It's going to force you to do 2 lines. Well, we want to be creatively lazy. We want to avoid doing more than 1 line wherever possible. So we're not going to start by making the conclusion false. We're going to see if we can start, if there's one of the premises that can be true only one way. And of course, an obvious candidate is here. So we're going to start by making F true. Because of course, it's a single letter, so there's only one way it can be true. And then we fill in the value for F wherever it shows up elsewhere. Now, where should we go next? Well, this one, we shouldn't go here. It's hard to think backwards when I'm moving this thing. We shouldn't necessarily go here because this one can be true because it's a conditional, can be true in more than one way. So again, we'd have to add lines if we went here next. So let's see if this one, which is after all a conjunction, can only be true in one way, or whether or not we can come up with values for some of the letters at least, that there's only one thing where they can be to make it true. So, well, actually one of them we can. Because it's a conjunction, both sides of the conjunction have to be true, which means, of course, this conditional has to be true. And we know that the antecedent is already true, so there's only one thing G can be to make the whole thing true, which is true. So we can fill that in. So G is true, and once we've done that, we can fill in G elsewhere. And that, so there's G shows up 3 times, and perhaps most important is in the conclusion. But it also shows up here. So we know now that the antecedent of this first premise is true. So I'm going to fill that in. Which means, no, I shouldn't circle it, I'll put a square on it. Which means, of course, that if that premise is going to be true, H has to be true. And then I can fill in H elsewhere. What I'm talking about is here, because we made the antecedent true, so for the whole thing to be true, the conclusion can't be, the consequent can't be false. So I made it true, and I filled in true under here. Alright, which means that the consequent of this conditional, because it's not H, is going to be false, which means that we have to make I false too, because otherwise we'll have true, false, and this conditional will be false. So I'm going to fill that in. So we have all of this, and that will make this premise true. The trouble is, so we made both premises true. No, 3 premises true. The first premise is true. We started by making F true, and now we've made this one true as well. But the trouble is, look at the values that we've plugged into the conclusion. When they're both the same, that means the whole thing is true. So we have once again failed to make all the premises true and the conclusion false. But in this case, where we failed is with the conclusion. That is true when it should be false, so that's where we put our arrow. And we write valid. Right here. So, with all the ones in practice quiz 13.2, the conclusion can be made false in only one way. So I wanted to show you, so usually it makes sense to start by making the conclusion false, but I wanted to show you one example where you would do the conclusion last. Not necessarily, because actually you could have done the conclusion before you did this one. So it's not the only way you could have done it. But if you do the conclusion last and it ends up being forced to be true, that shows that the argument is valid. Okay, I'm going to do one more example, and it's one I made up, and it's this one on the bottom. So, premise 1. If A then B, premise 2, if B then C, premise 3, C or D, and conclusion A and D. Give that a shot yourself for a second. I'll wait. Okay, what you probably noticed is that there is no premise or conclusion that can only be the value you want it to be, true for the premises, false for the conclusion, one way. And that's because I designed it that way to illustrate a point. So what this means is that you can't avoid adding lines to your shortcut method. Now, usually you only need 3 lines, which isn't too bad, but still, I wanted to show you a case where you couldn't just do it in a single line. So, it doesn't really matter where we start. If we start by making the conclusion false because it's a conjunction, there are 3 ways it could be false. We start by making any of the premises true because they're either conditional or disjunction. They can be true 3 ways. So let's start with the conclusion. I'm going to make it false, but because there are 3 different ways it can be false, I'm going to fill in all those values. It can be A can be false, D can be true, A can be true, D can be false, or they can both be false. Those are the 3 possibilities. Okay, so I've filled in the truth values here, the 3 different varieties that will make the conclusion false, and I've carried the truth values for each of A and D over here. And what we notice already is that in the rows where A is false, because A is the antecedent of conditional, the first premise is already true. And of course, also, where D is true, because that's a disjunction, that's going to make C or D true. Now, what we should see already is that because the 2 premises with the first and the last premise in the first row, here and here, are true, it's very easy to make the third one true. So, on the very first row, we will have succeeded in making all the premises true and the conclusion false. What that means is actually you only needed 1 row because you struck lucky with this combination, and you did succeed in making all the premises true and the conclusion false. However, if you failed on the first row, if it looked like you couldn't, suppose on the first row you couldn't make all the premises true and the conclusion false, that would normally mean that you have a valid argument. But because there are 2 other rows to do, you can't stop there. If you do prove on the first row that the argument is invalid, then you can stop, because invalidity trumps everything. When you proved invalidity on 1 row, that means, bam, the argument is invalid. But if you fail to prove invalidity on just the first row, that doesn't prove that the argument is valid because you have 2 more rows to check. It so happens that in this one, we did succeed on the first row. I'll just fill that in. And actually, what that shows is that this argument is so invalid that it doesn't really matter what the truth values are for B and C. Now, the only thing that you can't have is a combination where B is true at the same time that C is false. But you can have both of them be false, you can have B be false and C be true, or you can have both of them be true. So, the way we write that, because this is invalid, we write out invalid, and normally we list the truth values of each of the letters. And you can do that for A and D. You can say A is false and D is true, because those were the values that we filled in. Now, what do we do for the remaining 2? Well, ideally, we would indicate that there's more than 1 truth value that they can be. So perhaps I could just write it, I will write out this. Any combination except B true and C equals false. If you can see my handwriting. So that indicates that there's more than one possibility for making this invalid. And what that means is if you did the long table, which, if you remember, because there are 4 letters, there would be 16 rows on that table, it turns out that there would actually be more than one row where all the premises are true and the conclusion is false. There would be a row, on all the rows, A would be false and D would be true, but there would be a row where A is false, B is false, C is false, and D is true, and there would also be a row when A is false, B is true, C is true, and D is true, and there would be one more row as well. Okay, I think we have covered everything important about the shortcut method. But I want you to practice it because it's been my experience that this is the thing that people screw up most on the final. There will be several questions on this on the final, but because we've done it relatively early in the stuff that's going to be on the final, people tend to forget about it. So I want to make sure that you've got it thoroughly ingrained and you don't forget about it. So practice makes perfect. And of course, because this video is so short and so entertaining, you can watch it 20 times and that way you'll never forget it. Alright, see you in the next video.